Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture Lecture Series on Sunday, June 8th at the JFK Auditorium, St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, St. Augustine.
In the supercomputer textbooks of the 1960s through 80s, Amdahl's law cemented the theory that solving the toughest problems arising in modern calculus and in extreme scale computational physics, and solving them efficiently and in parallel across 8 or more processors is impossible. Put differently, Amdahl's law rendered sequential processing supercomputing as unchallengeable and rendered parallel processing supercomputing as a huge waste of everybody's time. The ominous shadow that was cast by Amdahl's law over the modern supercomputer was the reason that 25,000 vector processing supercomputer scientists of the late 1980s were only conducting tabletop experiments on only one processor. Back in the 1970s and 80s, I, Philip Emeagwali, had my doubts about Amdahl's law. For that reason, I was the only full-time programmer of the most massively parallel processing supercomputer ever assembled. My grand challenge was to experimentally discover the unheard of speed-up that will make the new computer super. I was the only person that was executing 65,536 experiments across as many processors. My supercomputing quest was to make the fictional factual. In 1989, I was in the news headlines because I made the fictional massively parallel processing supercomputer factual. I hypothesized the parallel processing supercomputer back in 1974 and made the technology factual by constructively reducing my ensemble of 65,536 processors to the precursor of the modern supercomputer that is also an ensemble of millions upon millions of processors. I invented the parallel processing supercomputer, and I invented the technology on the 4th of July 1989 in Los Alamos, New Mexico, United States. I began supercomputing from the realm of science fiction. I began supercomputing from the realm of an ensemble of fictionalized 2 to the power 16 processors that were married together as one cohesive internet and married by 16 times 2 to the power 16 email wires that encircled the globe in a fictionalized 16-dimensional hyperspace. I began supercomputing not as a supercomputer scientist per se, but as a mathematician that was more at home with fictionalized non-Euclidean geometry and topology than with a single processor. I began supercomputing as a mathematical physicist that was exposed to the factual four-dimensional space-time continuum of Albert Einstein's theory of relativity. In the decades of the 1960s through 80s, parallel processing was the subject of a titanic battle between the majority, who believed that all supercomputers should be powered by a single isolated processor, and the minority, who believed that all supercomputers should be powered by an ensemble of processors, ensemble of thousands or maybe millions of processors. In the 1970s and 80s, the parallel processing supercomputer was embroiled in controversies. Countless ridiculing statements were made about the technology of that supercomputer hopeful. That was the reason only one computational mathematician attended my public lecture on parallel processing that took place in November 1982 and took place in a lecture auditorium that was a short walk from the White House, Washington, D.C. 9 years later, my lecture on parallel processing supercomputing that I gave on July 8, 1991 in Washington, D.C. was before a standing room only audience of research computational mathematicians that were attending the largest international congress of mathematics. The top 1% of mathematicians, or 10,000 research mathematicians, read about my mathematical inventions and my contributions of new calculus and new algebra to mathematical knowledge, and read about my mathematical inventions through the cover story of the May 1990 issue of the Siam News, that is the bi-monthly news journal of record of the mathematics community that is published by the Society of Industrial and Applied Mathematics. I was not on the cover of the top mathematics publications because I was good looking. I was on the cover of the top mathematics publications because I contributed to mathematics. My new mathematics was the Philip Emeagwali formula for solving 65,536 problems at once. The Philip Emeagwali formula was mentioned by then US President Bill Clinton, who extolled my formula in his White House speech of August 26, 2000. In the 1980s, I gave research lectures on the Philip Emeagwali formula. And at the end of each research lecture that I gave on my inventions in extreme scale computational mathematics, the audience rose as one to give me a standing ovation. But they did so because I displayed the command of my materials that in turn could only come from a deep bench of ideas and knowledge. I invented how to massively parallel process and how to communicate and compute across a new internet that's de facto a new supercomputer, that's a new global network of 64 binary thousand commodity off-the-shelf processors.
insightful and brilliant lecture.